Welcome back to RaWMachines, the journey where we explore the most impressive industrial processes from around the globe. Today, join me as we step into the world of modern maritime engineering, where colossal ships are born, silent machines operate on the ocean floor, and high-stakes engineering missions unfold across the open sea. From construction, repair, and operation to salvage and decommissioning, it all forms a vivid picture of how humanity conquers the ocean. Let's get started. This video captures the entire birth and float-out process of the mega cruise ship, Spectrum of the Seas, owned by the Royal Caribbean Group. This vessel was constructed at Meyer Werft, one of the world's most prestigious and historic shipyards, located in Papenburg, Germany. The scene inside this vast hall is like watching a Lego set assembled on a surreal scale. Meyer Werft's indoor building dock is a massive advantage, allowing for 24/7 construction regardless of harsh weather, ensuring they meet strict delivery deadlines. We are now looking at one of the most critical mechanical stages, the installation of the Azipod propulsion system. Unlike traditional rudders, these motor units can rotate 360 degrees, providing powerful thrust and incredible maneuverability. This allows a colossal mass of steel to navigate through narrow sea channels with ease. Parallel to the hull welding, thousands of technicians enter the outfitting and systems installation phase. The cruise ship gradually transforms from a dry mechanical construction site into a mobile five-star resort. On the exterior, the name Spectrum of the Seas is officially painted with pride. Not every great engineering achievement is visible on the surface. The S-81 Isaac Peral submarine is a clear example of power that operates unseen. On April 22, 2021, in Cartagena, the vessel was officially launched, marking the culmination of years of research and development. At roughly 70 meters in length and nearly 3,000 tons in displacement, the S-81 is not massive in size, but it carries cutting-edge technology, most notably its AIP system, allowing it to remain submerged for extended periods without surfacing. Beneath its reinforced steel hull lies a highly advanced system of sonar, radar, and communications, integrated with weaponry such as torpedoes and missiles. All of it is operated by a crew of just 32, working in a sealed, high-pressure environment where even the smallest mistake can carry serious consequences. Following its launch, the S-81 entered a rigorous testing phase, with every system evaluated before it could officially join the fleet. This is the final step in transforming a technical achievement into a fully operational, strategic asset. The S-81 is more than just a submarine. It represents the ability to master complex technology, an invisible machine operating in the depths, yet capable of shaping the balance of power across the oceans. If the S-81 submarine represents hidden power beneath the deep sea, then the Bay of Cadiz is an entirely different world, a place where giants are reborn. Navantia operates 6 shipyards across the Spanish coastline, but Cadiz carries a unique mission. Thanks to their deep expertise, they have become a strategic partner for mega cruise corporations like Royal Caribbean. The selling point of the Cadiz yard lies in its strategic location right next to the Strait of Gibraltar, the maritime crossroads between the Atlantic Ocean and the Mediterranean. Cruise ships don't need to deviate from their commercial routes to pull in for repairs. Inside the yard is a massive industrial complex featuring a dry dock 386 meters long, capable of receiving vessels up to 440,000 tons, alongside a large-scale system of cranes, warehouses, and container facilities. But scale is only the surface. What sets Navantia Cadiz apart is how everything operates. Every day, the yard must provide a system to process 500 tons of wastewater, while simultaneously pumping thousands of cubic meters of high-pressure seawater continuously to cool the engines and run the air conditioning for the ship while it sits dry on land. Beneath the hull, workers dismantle propellers and inspect stabilizers using hydroblasting technology to remove marine growth before applying a new, eco-friendly coating. At the same time, up on the deck, scrubber exhaust filtration systems are fitted into the funnels, and hundreds of interior outfitters are busy refurbishing cabins and entertainment areas. These operations run 24 hours a day, 365 days a year. The Navantia Shipyard understands that, for commercial vessels, time is incredibly precious. Therefore, they always pour their full effort into doing the job right. A truly admirable spirit, isn't it? If you had the time, would you like to visit this place? Modern shipbuilding is no longer just about welding together massive steel sections. At Meyer Turku in Finland, the installation of the Aquadome represents an entirely different level of mechanical engineering. Instead of building upward piece by piece, Engineers assemble the entire dome structure at ground level. This approach reduces construction time, improves safety, and allows critical components to be completed in advance. More than just transforming the ship's appearance, the aquadome stands as clear evidence of something larger, that the limits of maritime engineering are still being pushed and continually redefined. The Norwegian Joy is one of the largest cruise ships in the world, but the journey to create it was far from the smooth sailing its glamorous exterior suggests. Constructed at the Meyer-Werft Shipyard in Germany, the vessel stretches over 320 meters in length, carrying thousands of passengers, a true floating city upon the ocean. The construction process began in 2014, with costs reaching hundreds of millions of euros. From the outset, the ship was designed using the modular method, where dozens of massive steel blocks were fabricated separately and then joined with near absolute precision. However, the reality of construction always contains unpredictable elements. During the building process, 2 small fires occurred, causing damage and forcing the engineering team to react swiftly. These incidents, though minor, served as a stark reminder that behind every gargantuan project lies a continuous chain of risks. Once completed, Norwegian Joy entered its sea trial phase in the North Sea, a harsh environment designed to test every system to its limit. From the engines and navigational capabilities to the structural stability of the hull, everything was evaluated under real-world conditions before the ship was officially delivered in 2017. What makes Norwegian Joy truly special is the sharp contrast it embodies. On the outside is a space of luxury, featuring a 2-level go-kart track, dozens of restaurants, and modern entertainment zones. Yet, hidden within is a complex engineering system operating continuously with clockwork precision. One side is the experience, the other is the engineering, and both must function perfectly at the same time. Norwegian Joy is not merely a cruise ship. It is a testament to the fact that the grandest structures are always built from the smallest details. It is through the process of overcoming these challenges that the true value of the work is confirmed. Building a nuclear-powered supercarrier is considered the pinnacle of American defense engineering. The video begins inside a gargantuan, empty dry dock. One by one, massive supermodules forming the keel and lower hull are lowered into place and assembled. The constant shift between day and night reveals the scale of the process, stretching across years of continuous work. Gradually, the ship rises, bulkheads take shape, and critical compartments, including the nuclear reactor spaces and aircraft hangars, are enclosed. This is the most iconic moment in carrier construction. A giant crane lifts the island structure, weighing over 500 tons, and places it onto the flight deck. Compared to earlier generations, the island on the Ford-class carriers is smaller and positioned further aft, maximizing deck space for aircraft operations. Once the steel hull is complete, millions of gallons of water flood the dry dock, marking the end of structural construction, but only the beginning of the ship's 50-year service life. The USS Gerald R. Ford is more than a 100,000-ton floating structure. It is a mobile military base, a demonstration of mechanical and technological power, and a strategic instrument on the global geopolitical stage. At the Foss Rainier Shipyard, the berth of the Nicole Foss is a masterclass in durability, gravity calculations, and heavy lift logistics. This vessel was engineered to endure the harshest conditions of Arctic waters. Consequently, its steel hull and framing systems feature specialized reinforcement. The construction strictly applied modularization. The bow and stern sections were welded upside down to optimize access angles for the workers, ensuring the highest possible weld quality. The process of flipping these multi-ton steel blocks requires absolute synchronization from a system of heavy-duty cranes. The logistical challenges became most apparent during the launch phase. The massive hull had to be transported via self-propelled modular transporters onto a floating dry dock. It was then towed along the river to find an area with sufficient depth and space for the dock to be submerged. Specialization is further demonstrated in the final equipment integration. The main engine cores and the ultra-heavy-duty towing winch systems were installed directly via floating cranes after the ship was afloat, before the pilot house was joined as the final piece of the puzzle. The Nicole Foss is not a vessel focused on speed or sleek aesthetics. It is a true industrial machine, a gargantuan power station on the water, designed for relentless operation amidst icy seas and the world's most unforgiving maritime environments. Deep beneath the ocean's surface exists a nearly invisible, yet immensely vital system: offshore pipelines, transporting oil and gas across distances of hundreds of kilometers. They operate in silence, yet they hold a life-sustaining role for the global energy industry. The process begins with seabed surveys using sonar and geophysical technology to identify a safe route. Subsequently, pipe segments are manufactured, treated with anti-corrosion coatings, and transported out to sea. Once on site, the installation process commences using various methods such as S-lay, J-lay, or reel lay, depending on the depth and terrain conditions. Each pipe segment is continuously welded and quality checked on the spot, while tension is strictly controlled to prevent deformation. Upon completion, the system undergoes pressure testing and internal cleaning, and is often buried to protect it from the harsh environment. All of this ensures the pipeline can operate reliably for many years. The uniqueness lies in this: a gargantuan engineering feat that impacts entire economies exists in total silence on the ocean floor. This is a different form of conquest, unassuming, yet resilient and essential. These pipelines are not just engineering projects. They are a testament to humanity's ability to extend its reach to the very bottom of the ocean, From these hidden structures, we can look back at the entire journey, where every project, whether above or below the water, contributes to shaping how mankind conquers the seas. The maritime industry is not only defined by record-breaking construction, but also by rescue operations that demand extraordinary precision and courage. The case of the cargo ship Modern Express in 2016 stands as a striking example. On January 26, 2016, the 164-meter roll-on/roll-off vessel encountered a severe storm in the Bay of Biscay. It lost stability and developed a heavy list. All 22 crew members were evacuated, leaving behind a drifting mass of steel threatened by capsizing and potential oil leakage. As the vessel drifted rapidly toward the French coastline, the critical task was to secure a towing line and bring it to safety. On January 29th, a helicopter deployed 4 specialists onto the dangerously tilted deck, but strong winds and heavy seas forced them to abort the attempt. By February 1st, with the ship just 25 nautical miles from shore, the rescue team made a final attempt. A second helicopter insertion was carried out. This time, through precise coordination and remarkable courage, the team successfully secured a tow line to the tug Centaurus. With international cooperation and approval from the port of Bilbao in Spain, the vessel was safely towed to land. But the operation was not over. To right a massive vessel that had been heavily listing, engineers carried out a complex ballasting and deballasting process. High-capacity generators and pumps were brought in to carefully control the flow of water into and out of the ship's ballast tanks, following detailed engineering plans. After 3 weeks of careful work, the vessel was finally restored to a stable, upright position and returned to its owner, bringing a historic rescue operation to a successful close. The offshore energy industry faces more than just the challenge of construction. It must also manage the aftermath when structures reach the end of their lifespan or are devastated by powerful storms. Dismantling multi-ton oil rig jackets under turbulent sea conditions is an immensely complex technical and environmental hurdle. The Versabar VB-10000 heavy lift vessel was engineered as the most definitive solution to this problem. Boasting a lifting capacity of up to 7,500 tons, the VB-10000 features a unique design: two parallel floating barges connected by a colossal arched space frame system. This architecture transforms the vessel into a giant mechanical tweezer on the ocean. Rather than deploying divers to cut the rig into small pieces underwater, an incredibly costly, dangerous process with a high risk of chemical leaks, the VB-10000 utilizes single-lift technology. The machine advances directly toward its target, positioning its dual hulls to straddle the wrecked platform. The entire twisted steel structure is hoisted from the sea in a single pulling cycle, after which a transport barge is maneuvered underneath to receive the load. This aggressive yet precise approach has slashed seafloor clearing timelines from months down to mere days. Performing a single-piece removal not only eliminates life-threatening risks for subsea salvage teams, but also serves as the most thorough method for preventing environmental disasters, clearing industrial ruins to restore the ocean to its original state. Looking back at the entire journey, from the magnificent mega-cruise ships and silent submarines, to the colossal aircraft carriers projecting military might, or even the invisible offshore pipelines and high-stakes salvage operations, it all converges into a single, grand picture. The portrait of humanity's ambition to conquer the seas. It is a journey that is far from simple. Every vessel launched is not just the result of millions of labor hours, but a perfect harmony of science, engineering, and wisdom accumulated across generations. And in every rescue mission, the human element, courage, responsibility, and the ability to decide under pressure remains the ultimate deciding factor. A striking contrast runs throughout. Some structures showcase pure luxury, while others operate silently in the shadows. Some projects are commercial ventures, while others are symbols of national power. Some are built to last decades, and others are dismantled to restore environmental balance. Yet, regardless of their form, they all serve a singular purpose: to expand the boundaries of human reach upon the ocean. The sea, one of the harshest and least controllable environments on Earth, has become a place where humanity does not just survive, but masters. From transportation and resource extraction to territorial defense and environmental restoration, Every step forward marks a new milestone in our technological capability and organizational mindset. Perhaps what is most significant is that these feats do not lie solely in what we can see. Most of the true value is hidden behind the scenes, in technical blueprints, in every weld, in tireless operating systems, and in the people quietly standing behind it all. Ultimately, the journey to conquer the ocean is not just a story of machines or structures. It is the story of humanity itself, a species that never stops exploring, never stops pushing limits, and always finds a way to turn the seemingly impossible into reality. As we look out at the vast ocean, we realize that what has been achieved is merely the beginning of even greater journeys ahead. Thank you for listening to the end of the story. If you enjoy videos like this, please like, share, and subscribe to the channel so you don't miss the next stories. RaWMachines says goodbye and see you again.